probability distribution of random variables. We only need the value of x, which is about the number of eggplants with worm attacks, and the probability. Then, create a histogram from this. So, the vertical side is the probability, while the horizontal side is the value of x, or the number of eggplants with worm attacks. So this is how our histogram look like a bell shape or a normal curve. Next, how do we find the mean of the probability distribution of random variable? So we're talking about mean. We use the same table and we're looking for the mu, or the population mean. How are we going to do that? The mean is the average of all possible outcomes. It is otherwise referred to as the expected value of a probability distribution. So when we say expected value, it means that if we repeat any experiment infinite times, the theoretical mean would be the expected value. Using the same table, let us solve for the mean. This is how we solve for the mean. First is, the first column is multiplied by the second column. The product here is the third column. Each of the elements in the first column is multiplied to the elements of the second column and written on the third column as the product. After getting all of the products, we sum up the product. So we have 3 plus 6 plus 3 is equal to 12 over 8. We did not include 0 anymore because even if we added 0 here, the result will still be the same, 12 over 8. We simplified 12 over 8, we have 3 over 2. And 3 divided by 2 is 1.5. So this is our mean. Next is, how do we solve for the variance? Using the same table, the probability distribution of random variables with our mean equal to 1.5 here, this is how we solve for the variance. We use the first column minus the mean of 1.5. This is equal to the fourth column that we have added here. So that is 0 minus 1.5 is negative 1.5. 1 minus 1.5 is negative 0.5. 2 minus 1.5 is 0.5. And 3 minus 1.5 is 1.5. After that is, we square each member of the fourth column. So after we square all of the values in here, we added another column, and this is labeled x minus mu quantity squared because each of the values under this is being squared. After squaring it, we get the value from the probability of x, or the p of x. You multiply that to the quantity of x minus the mu squared. So the result is written as additional column. After that, we get the sum of this column, and we have the variance. Symbol for variance is sigma squared, 56.4375. This is our variance. Next is, let us find the standard deviation. How do we solve for the standard deviation? First is, we simply get the square root of the variance. The square root of the variance is equal to 7.5125. So therefore, the standard deviation of this probability distribution of random variable is 7.5125. So what I have learned in this lesson is that discrete variables are finite variables and they are obtained through counting, while continuous variables are infinite variables that are obtained through measurement. These are the formulas for finding the mean, variance, and standard deviation. Now, the total area under the normal curve is always equal to 1. Or if you change that to percent form, that is 100%. The normal curve is symmetrical to the mean because the mean is at the center of a normal curve. So from the right of the mean to the left of the mean, they are equal. Next is the area under the normal curve is found in the z-table. So if you're asked to find the area under the normal curve, you look for the z-table. So I hope you're enlightened. Good luck in your learning activity sheet number 1 of the 3rd quarter. That's all for now. See you next topic.